Hi everyone, I'm Dr. Nick Bierman. It's great to have you back for this next video in our Foundations of Research Data Management for GIS course. Today we're going to talk a little bit about FAIR principles and GIS. So let's get started. So we're going to start off with a FAIR recap. So FAIR is findable, accessible, interoperable and reusable. And this is all about how we implement the FAIR principles for data. And doing this can be a challenge. You know, there's no getting away from that. It's not the easiest thing to do. And we also applying them to GIS data is even more of a challenge because we've got some specific issues with GIS data. The key thing that I really want you to get from this video is that the idea is to work towards the FAIR principles. So it's not an end goal as such. It's not either you're fair or not. You work towards it. So you make your data more fair. And one of the big benefits of this is helping you answer the most common questions people have about your data. And if you do it well, people can look at the data and look at the information surrounding it and answer the questions themselves and not even have to bother you. So that's a big win. So that saves you dealing with questions about your data. So just a very quick recap. What is FAIR? So F is for findable. And usually we adopt an approach of attaching a DOI to your data. So for example, upload it to Zenodo and provide rich machine readable metadata. So this could be information on this format, when it was collected, all that kind of stuff. A is for accessible. So it's all about explaining how can someone access your data? Where can they download it from? What software do they need to use it? It's worth pointing out that FAIR is not the same as open. Open data, anyone can download. FAIR data, you provide the exact conditions of accessibility. So if people have to apply for the data, you can still count that as fair as long as you document how to apply for it. You know, who do you have to apply for, how long it will take, all that kind of stuff. So I is for interoperable. So this is usually around using common data formats. So thinking about non-spatial data, CSV, JPEG, and so on. And there might be formal standards to say that, say, you always use this format, or there might be what we call community standards. So this is what is a kind of de facto standard. So this is the standard that everybody uses. Nobody actually formally has said this format is the one you should use, but it's the one people always use. So that's how we work out what that is. And also clear documentation for your data, particularly column names, for example. So if you're dealing with tabular data, make sure the column names are clear. And this can also include context. So is your data used elsewhere? So this could, you know, be a list of we've used this data in previous articles, or this could be a more formal documentation like a public knowledge graph. So for example, Wikidata, and then you can relate data to other data as well. And lastly, R is for reusable. So this is helping others to reuse the data. So this can be machine readable metadata, which we talked a bit about already, and also licensing your data. So being clear on what are the license conditions for using your data. Usually some of the Creative Commons by licenses are a good place to start. So that's what FAIR is. How do we apply this to GIS? Because we have some specific issues with GIS data. So we start off with F, so findable. So what data did you use? A DOI is ideal, a URL is okay. Sometimes with big geospatial data, particularly very commonly used data sets, you get different versions. So Natural Earth or OpenStreetMap as a great example. Natural Earth is a very good base map data, and they do release versions on GitHub. So if you download a version, it will have a version tag. So like the example here, 5.1.2. So that's a good way of versioning it. Solely for completeness, it's worth saying that Git history can change, repositories can be renamed or deleted, so it's not completely infallible, but it's a good starting point. OpenStreetMap is another example. They don't have versions of OpenStreetMap data as such, it's not versioned, but you can record a URL of the data you access. So this is one example. So you can use the API and say, we get the data from this bounding box. So here's some coordinates to give us a box, and then date stamp the date time of access, because OpenStreetMap is updated all the time. So if you've got a date stamp, someone else would be able to recreate the data at that point in history. A possibly more useful way is to save a snapshot of the data, and you could submit that with the supplementary materials of your paper, and that would then get a DOI, and that would be a snapshot of whatever data you're working with, say, for example, roads data. Or you can save the data and upload it separately to a data platform, so like Zenodo, for example, and that will give that data set a DOI. And you can add multiple data layers. So you can have 3 or 4 different layers all under one DOI, all data that you used for a project, or however you wish to organize that. It's also worth mentioning a little bit, it's worth thinking about project data and geodata separately. So some data, geodata specifically, geodata is the general stuff, and you may or may not need to store that. We'll talk about that in a minute. Project data is specifically for this project, and you probably will need to store this. So on that kind of geodata, general stuff, is your data going to be available long term? Yeah, if you use something like Natural Earth or anything like that, you think it might be. But in January 2025, this appeared in various places on various different bits of the US government. This file is deleted by executive order. And this was all to do with the Donald Trump's administration removing various different web pages and data sets, about 8,000 web pages and 3,000 data sets. Usually stuff related to diversity, equity, inclusion, gender identity, public health, environmental policy, social programs, and so on. Stuff that Trump and the Republican Party didn't like. So stuff you thought might be there may not still be there. How is that likely to happen? Don't know. There's a lot of stuff that disappeared that we wouldn't have thought did disappear, but a lot of stuff did come back as well. So it's a balancing act. And it's worth pointing out this is not just an issue in the US. So there's been a couple of cases in Australia where data was stored in what was thought to be a long-term repository, and then it disappeared. And there are other subtleties, particularly with archiving data. So in the UK, often historical data on government sites is removed or replaced. So in the UK, we have a data set called the Indices of Multiple Deprivation, IND, and a new version comes out every 5 or 6 years. And it's really useful for looking at social mobility and deprivation, a whole range of factors, and a lot of people use it. But very frequently, the new version replaces the old version on the government side. So if you want to do any archive research, any historical research, that gets quite hard. We have something called the National Archives, and they have a snapshot of the data as it was. So this is an example for Indices of Deprivation 2004, and you still can get the data from them. But the archive is only an Excel file. It's not a shapefile, so there's no spatial boundaries associated with this. And as a group I spent a bit of time working for, the Geographic Data Service. They're a research group working in UCL, and they did have some archive data of the IMD and some shapefiles. So they took it upon themselves to make this a bit more accessible than burying it in the National Archive. But they didn't have shapefiles for all of the years, and they vary depending on the census. So for example, they've included the 2011 LSOAs, which were the most recent ones. We'll get to that in a minute, but not the historical ones. So they had the 2004 data, but matched to the 2011 boundaries, not to the 2001 boundaries. And so this is great if you want to do historical work now, but they suffer from the problem that we had another version of IMD data out last November 2025, and that has a different set of boundaries from the 2021 census. And so they need to update all of their data to match that. So it's a constant process to try and keep this up to date. So if you want to store a snapshot of something, I'd really recommend you store the attribute information, so the attribute table, but also the spatial element as well, whether in a shapefile or geopackage or whatever format it is. We'll get to that in a bit. And you can do this using a DOI. And for example, if you upload a dataset to Zenodo, they'll give you a DOI snapshot, and that will be there, for permanence, as far as we can tell. And it's also useful to provide rich machine-readable metadata. So Zenodo does a lot of this work for you. So it asks you a few questions about what it is and what it covers and that sort of thing. And that goes into their system. So if people want to search, they can search by type as well as name and a whole bunch of other stuff. This was an interesting article at their Agile conference last year. MapVerse, so map usability, validated empirical research by systematic evaluation. They really shoehorned that acronym in, but they did a review of where people stored spatial data for reproducible research. They ended up with 9 studies. 4 of them stored data in Zenodo, 2 of them stored data in Figshare, and 3 of them stored data in the Harvard Dataverse. So it's a nice example. Zenodo is probably the most popular, easiest to use, and that's the one I'd recommend. So when we're thinking about accessible with GIS data, how can you access your data? So make sure it's clear where someone can get your data from. Can they download it from a website, or what the DOI is? Do they have to apply for it? What's the application process? And so on. And it's worth saying again, fair is not the same as open. Open data people can just download. Fair data, you just provide the exact conditions of accessibility. So if you have to apply for it, that's fine. If your application has to be reviewed by a committee and approved and this, that, and the other, that's fine as well. When you're reporting what you did, be clear on what version of the data you used, or possibly what date you applied for it, or when you got it, or whatever information is provided when you receive the data. And the other element of accessible is, did you need to convert it? What format did it come in? So if it's an unusual format, how do you document that? And that kind of leads us into Interoperable as well. So it's really recommended to use a common format. So what is a common format? Well, it depends. There's nothing specifically specified. It's what we might call a community standard. So for GIS data, I would say that's probably a shapefile, a geopackage, or a geotiff. Those would be the kind of 3 most common formats, depending on what data you're working. If it's in a different format, use your judgment. Who's likely to be using your data? Are they likely to know what that format is? And if they're not, or you're not sure, either include it in a standard format or include some information to how you convert it. There is an approach that any format supported by GDAL would be fine, which is a wide list of things, but it really depends on your situation. So there's no kind of specific guidance. Think about who's going to be using it. And the other side is column names. So making sure you have clear column names. Sometimes, for example, shapefile column names are restricted to 8 characters. If that's a problem in your setup, use a geopackage instead. You have much longer column names and you can be very clear about what the column is. And you can also reference where your data has been used elsewhere. So whether it's referencing papers or add it to a public knowledge graph, for something like Wikidata, you can do that to say, how does your data fit into the wider setting? In terms of archiving, we don't really have any archive formats for GIS. The standard formats are fine. Other areas have very specific archive formats depending on what they want to do. But for GIS, shapefile, geopackage, geotiff is fine. If you're using some other format for some reason, do say why. And lastly, R for reusable. So how do we make our GIS data reusable? So make sure you have machine readable metadata. So if you upload something like Zotero, this is already supported. License your data. So Creative Commons is a great starting point for licenses. And we also have what we call machine readable license identifier. So SPDX is one of these. And this is a machine readable version of the license. Says, okay, this is the license, this is what you can do with it. I've not been able to find any dedicated geospatial data portals. Generic ones are fine. Zenodo is a good example. Figshare or Harvard Dataverse are other ones as well. We do have a whole area of metadata with GIS. So Inspire is the framework for this, and there's a couple of guides on there. And then UK Gemini is how we implement that in the UK. In my experience, the kind of application of this has been variable. So it really depends what area you're working in, whether people do this. If they do, then do that. Even if they don't, it's still worth including this information in a plain text file, in a readme.txt, or at least the minimum of what it is and where you got it from. So I hope that's been an interesting go through FAIR principles for GIS. Thanks very much to NFDI4Earth and the Digital Research Academy and everyone who contributed to this. Looking forward to seeing you in the next session.